For number 1, we have our points here and we're asked to find distance between the points. So we have here 1 and 5 and negative 5 and 3. So to solve this, let us identify our x1, which is 1, and our x sub 2 is equals to negative 5, and y sub 1 is equals to 5, and y sub 2 is equals to 3. So to solve for the distance, we can use a formula. Distance is equals to square root of quantity x sub 2 minus x sub 1 squared plus quantity y sub 2 minus y sub 1 squared. So now we can plug in our given. So distance is equals to square root of quantity negative 5 minus 1 squared plus quantity 3 minus 5 squared. So we will get a square root of negative 6 squared plus negative 2 squared. And to simplify, we will now have 36 plus 4. And now we will get our square root of 40. So if we simplify this, or if we use our calculator, we will get 2 square root of 10, which is our distance. So number 2, we have now here the points, which is negative 2, negative 4, and 1, and 6. So we will going to do again the same process. So our x sub 1 is equal to negative 2, and our x sub 2 is equals to 1. And our y sub 1 is equals to negative 4, and our y sub 2 is equals to 6. So now we will going to use our distance formula. Now we have here distance is equal to square root of quantity 1 minus negative 2 squared plus quantity 6 minus negative 4 squared. And to simplify, we have here square root of 3 squared plus 10 squared. And if we simplify this, we will get 9 plus 100. And to simplify again, we will get our distance, which is square root of 109. For number 3, we have here again our 2 points, which is negative 3 and 4 and 3 and 6. And simplify again, use our formula, our distance formula. Now we have here 3 minus negative 3 squared plus quantity 6 minus 4 squared. And we have here square root of 6 squared plus 2 squared. If we simplify, we will get a square root of 36 plus 4. And if we add them, we will get square root of 40. So our distance will be 2 square root of 10. For our number 4, we have here again our points, which is 8, 1, and 0, negative 5. So the same process again, use our distance formula, and we will get square root of 0 minus 8 squared plus negative 5 minus 1 squared. Distance is equal to square root of negative 8 squared plus negative 6 squared. If we simplify, we will get square root of 64 plus 36. And if we add, we will get square root of 100. So the square root of 100 is equals to 10. So our distance is 10. For number 5, we have here our points, 1 and 3 over 2. Then we have negative 7 and negative 5 over 2. So again, to find their distance, we need to solve using the formula. distance is equals to square root of quantity negative 7 minus 1 squared plus negative 5 over 2 minus 3 over 2 squared. And if we simplify, we will get square root of 8 squared plus negative 4 squared. So square root of 8, if we simplify, 8 squared is equals to 64 and negative 4 squared is equals to 16. So if we add, we will get square root of 80. So if we simplify, our final answer will be distance is equals to 4 square root of 5. Next, we need to find the distance of our 2 points, negative 2 over 3 and negative 3 over 4. And our next point is 5 and negative 5 over 12. Again, we will use our distance formula. So this equals the square root of quantity 5 minus negative 2 over 3 squared plus quantity negative 5 over 12 minus our negative 3 over 4 squared. So if we simplify, we will get square root of 17 over 3 squared plus 1 over 3 squared. And 17 over 3 squared is equals to 89 over 9 plus the square of our 1. If we multiply 1/3 by itself, we will get 1 over 9. So if we simplify, we will get square root of 290 over 9, or the distance is equals to square root of 290 over 3, or 1/3 square root of 290. For number 8, we are asked to show that the point 2, negative 2, 5, and negative 2, negative 1, and 4, minus 1 all lie on a circle whose center is at 1, 2. So we need to find the length of the radius. So to solve this problem, first we need to plot our points. So our center is 1, 2, and our points here, which is negative 2, 5, negative 2, negative 1, and 4, negative 1. As we can see here in our drawing, we can see that they all lie on circle. All the points are touching here, the circle. So if we solve, we can, using the distance formula, we can calculate their radius, or the radius of the circle. So we can choose either one of them, the points, except the center, because we was going to solve our distance from the center. So we have here distance is equals to, in this case I chose 4 and negative 1. So we will have here square root of 4 minus negative 1 squared plus minus 1 plus negative 1 minus 2. So if we simplify, we will get 3 squared plus negative 3 squared, and if we simplify, we will get square root of 9 plus 9, or square root of 18. So if we use our calculator and plug in square root of 18, we will get 3 square root of 2, and that is our distance from the center to the other point, or that is our radius. For number 9, we are asked to show that the point 4, 5, 1, 1, and negative 2, 5 are the vertices of an isosceles triangle. So we need to find the area. So same process, we need to plot our points to see the triangle. So now we can solve for the distance. So first, let's solve the distance of 4, 5, and 1. 4, 5, and 1, 1. So if we solve that using our distance formula, we will get 5. And in the second one, we will solve for the distance of 2, 5, negative 2, 5, and 4 and 5. If we solve this, we will get 6. Next, if we solve our negative 2 and 5 and 1, 1, we will get 5. So as you can see here, we have the measurements of our sides. So we have here 5 and 5. Since isosceles triangle has two congruent sides, we can assume that 6 is our base. As you can see here in the drawing, we can cut the triangle into 2 and we will have a right triangle. Since we have a right triangle, we can use the Pythagorean theorem or the Pythagorean formula, which is a squared plus b squared equals c squared. In this case, our a is 3, and our b is our h, or the height, and our c is our hypothesis, which is 5. So if we solve this, we have here 9 plus h squared equals to 25. So our h squared, if we transpose a 9 to the other side, we will get 25 minus 9. So we square both sides, and our height is equal to 4. So to solve for our area, we know that the formula for the area of a triangle is base times height now times 1/2. So we can plug in, so our base is 6 and our height now is 4 over 2. So our area is equal to 24 over 2, or our area is equals to 12 square units. For number 10, we will show that the point -1, -2, 2, 1, and 3, 6 are vertices of a right triangle. So we're asked to find the area. So in this problem, we can use the formula to find the area of our triangle is equal to 1/2 quantity x sub 1 quantity y sub 2 minus y sub 3 plus x sub 2 quantity y sub 3 minus y sub 1 plus x sub 3 quantity y sub 1 minus y sub 2. And if we simplify this, we will get 1/2 quantity -1 and quantity 1 minus 6 plus 2, 6 plus 2 plus -3 times -2 minus 1. So if we simplify again, we will have here -1 times -5 plus 2 times 8 plus -3 times -3. Now we have here 5 plus 16 plus 9. If we calculate them or add them, we will get 30. And since we have here our 1/2, we can multiply the 1/2, so we will get 30 over 2. And our area is equals to 15 square units.